Good morning, everybody. Also, I want to thank the organizers to invite me and have me here on this wonderful conference. I really enjoy the atmosphere and the open discussion. I was asked to have a talk on risk factors for AMD and their relationships with the macular carotenoids. So let's start, and to get myself going, I start with some slides which are very familiar to all of us, but this is just to get me going. This is what AMD is and what it's, in the end, it's what our patients experience. So there's no real cure. So prevention, that's really an important issue, and that's what we're all here for, to prevent this end stage. Well, it came up several times. This is the original paper of Joanne Senna. How can you prevent? And she, in 1994 already, and that's what, when I was entering this field, as a matter of fact, she came up with this study where she showed that having a lot of spinach decreases your risk for AMD. And then when they look for the ingredient what would be causing this, then they came up with the lutein. Well, you saw this slide several times. So how about lutein? Well, then macular pigment comes into. And this is from a recent paper from Poyner, where you can beautifully see the yellowish in donor eyes, in normal donor eyes, the yellow pigment. And well, all of us are familiar with this slide from Max, where you can see where it's in. It's in the middle of the fovea we show, and where it's in the fovea, the outer segments, probably the Brooks the Muller cells, who knows. And there are possible biological hypotheses because macular pigments, they scavenge free radicals, they are a blue light filter, and they inhibit inflammation, and these are all processes ongoing in age-related macular degeneration. So let's now, after this introduction, move on to my talk. There are a number of possible risk factors, as we have heard yesterday. Age, diet, smoking, gender, iris, sunlight, BMI, physical activity, genetics. And the question is, which I want to address, is if you look at macular pigment, are these risk factors in some way related to macular pigment, or are they independent? So for instance, does macular pigment decrease or increase with age, or does it not? And if not, then they are independent. For instance, if they would decrease by age, then you could say, well, this age effect of the AMD, that's caused by a decrease in macular pigment. So that's what I'm going through one by one. And I'll do this in, I guess, this order. So let's start with age. There are many papers on the age effect. I'm a non-believer, so I think age is no issue in the macular degeneration, although there are some people who saw some effect. What I'll do is, I went to the literature, I probably forget a few, but I come up with many graphs, figures from papers I've seen, and I started with the flicker photometry method. This is a paper, a very early one, from Jack Warner, showing well, no age effect. Then there is another one from Julia. Do I pronounce it right? I don't know. Julia, I'm sorry. Also using HFP, and you see here a correlation of 0.06. So no age effect. This is a paper from Malario from London, with a lot of people doing age effects. Well, definitely no age effect, I would say. And a similar one from this Chula. I'm sorry. No age effect at all. Many subjects, no age effect. Small age effects seen by Randy in 2000. But I must admit that the Waterford group, they consistently see a strong age effect. Look at this graph. This is from another paper from the Waterford group. This is even, it looks stronger, but notice this is not zero, so the scale is differently. But nevertheless, you see an age effect. I don't know why. I can speculate. We did some HFP measurements ourselves, and look up there, we saw a slight age effect too. But then we went to the individual sensitivities. You remember you comparing a foveal to a parafoveal site. And what we noticed was in the parafovea, we saw an increase with age. So, and if you compensate for that, then apparently this gives you this, it's more or less an apparent decrease, only caused by this increase at the parafovea. So I don't know whether this is the cause, but anyway, it's a thing to consider in HAFP. So let's move on to another technique, psychophysical one. This is color matching from Davies and Moreland, and they don't see an age effect over a wide range of ages. Well, the technique I'm involved with a lot of reflectance. That let's say you just look at the light reflected from the retina and you analyze this, and then you get an absolute value of the macular pigment. And we did this a lot in many subjects. These are 2 studies with a lot of subjects, and as you see, well, there's no age effect present. This is another study with 138 subjects, no age effect as far as I'm concerned. François Delory did a study with many subjects, no age effect. From a Japanese group, no age effect. Another Japanese group who looked at the width of the distribution, and they found a slight increase with age. So that can happen too. So no age effect in reflecting technique. Let's go to another technique, the autofluorescence. It was mentioned yesterday. We did also this, and we saw no age effect. Neither did François in Boston. Trischmann Maike Trischmann in Sebastian Wolf groups. She did not find an age effect. A small decrease by a group from Germany, but not clinically significant, I would say, published in 2005. Again, what was this correlation coefficient? A small positive age effect, so an increase with age, in a recent publication in IOVS using autofluorescence, so that can happen too. And from Mustermeier, also no age effect. He said this line. My point is getting weak. Then let's move on to another, optical technique. I won't say objective. I agree with yesterday's speaker that it's just a matter of describing. It's not something that you an opinion about it. But anyway, this is a Raman technique, and they saw a very strong age effect at that time. There was a real heavy debate ongoing in literature, but it may be caused by pupil effects. This is from the Waterford group, who compared the HFP with the Raman, and they also saw this very strong age effect. This is the yellow line, but then they threw out all subjects with small pupils or unknown pupils, and all of a sudden the age effect disappears. So it may well be that this pupil and the elderly people gets smaller. Well, maybe we could have some discussion at the end on this. But that's what we're here for. Then let's look at donor eyes. This is earlier work from Brown. No age effect. Handelman, I would say no age effect. Another paper from Richard where he sees, essentially no age effect, I would say. And then there is work from Bozala from 2007, and you look only at the open circles and squares. These are the normals over a wide range of ages, and they see no age effect in donor eyes in the macular pigment. So as far as I'm concerned, these are independent factors. Age is independent, and it's not caused by the macular pigment decreasing in time, and this causing an extra burden on your retina, because more blue light enters your retina when you age. So now let's move on to diet. And apparently there's a big effect over there, we've heard, but nevertheless let me summarize some of the results in literature. This is one of Milerius' work, who started also with a very simple questionnaire. did you serve the servings of fruits and vegetables and eggs, rich in diet, I think 5 times a week, or less than 5 times a week. And if they discriminated between the two, then they saw this significant difference between the high and low, or the poor and the good diet, rich diet. This is a paper from Burke in the Journal of Nutrition. Sorry for the mistake in the spelling, where you definitely see a correlation between intake and the macular pigment density. Look, these are the symbols for the dietary intake, so there's a correlation ongoing there, as has been shown by Richard. Yesterday, Julie came up with this poster, and she said, well, dietary lutein alone weakly predicts macular pigment optical density. So that would contradict what I've said. And I was worried a little bit, because I thought, well, I can't remember this being from our publication. So I looked it up yesterday evening, and this is what's in this paper. Look at the numbers. Well, the point is not working anymore, but the third column, you see that it increases with increasing dietary intake. And in fact, this is the conclusion from their abstract. MPUD is directly related to dietary intake of lutein. So maybe you can comment on this later. As far as I'm concerned, diet relates, as they conclude, to lutein. And so dietary intake relates to MPUD. This is Elizabeth Johnson and Martin Neuringer's work, where you can see that it's really important to have lutein in your diet. If you raise monkeys with a lutein-free diet, then you see no macular pigment. This is a red and a green image. So, well, macular pigment absorbs bluish light, does not absorb greenish light, so you would see a difference. And if you don't see a difference, then it means there's no macular pigment. This is along this white line, the amount of macular pigment. And you see if a monkey raised free of lutein has given afterwards lutein, then all of a sudden it appears, the macular pigment. So yes, you really need it in your diet to have macular pigment. So there are some supplements, of course. Well, supplements, they do work. There are a lot of studies on this. I won't mention them all, but you see, well, if you use supplements, you end up in the higher range of the macular pigment density. This is recent work where they also see very significant differences. Look at this, I showed you this graph. These blacks now, were subjects on supplements. So if you compare them, then you see they are really having a lot of lutein in their eyes compared to the normals. We did ourselves some supplementation study, and we saw an increase in time having supplements. This is a graph from Richard's work which we discussed yesterday, where you saw an increase, and after stopping the supplementation, it went on. So I made a comment yesterday, and I looked it up yesterday evening, and I included this one. It can even be stronger if you do have a zeaxanthin intake. This is it's one subject out of 3, but they all had a similar time experience. So they were supplemented for some days, and then they were measured constantly. Unfortunately, since the lab in Utrecht was broken down, it stopped over here. But you see, they even increased. So it's with the zeaxanthin. That could be because of a store somewhere inside your body causing this. Well, others did too. Randy did some work on it. This is a paper from the Manchester group showing that not only in normals it can be increased, but also in aged ARM eyes. So you see also an increase. So it can help also in age-related macular degeneration. So that Mike Triesman, you see an increase in ARM AMD subjects. Richards worked, who did a supplementation study, who for the first time saw a functional effect. But look, these are AMD subject, and they increase also their macular pigment density. independent of the stage of AMD you're in. So even the worst, in the end stage, you can still increase your macular pigment. Clinical relevance of this is well in debate. These are recent work from Richer, again showing that in AMD subjects you can still raise your macular pigment. And this is the final slide which I come up with from Bones' work from last year, where he tried to have a review, I guess, from the literature and do a kind of dose-response relation. And you see it's more or less linear, with big standard deviations, which may be caused, as we discussed, by non-responders or by difference in technique or an uptake. But well, you see that it's more linear, and well, for very low intakes, you may need a certain amount just to start. For some studies, apparently, from this graph, showed no effect. We can discuss it later on a little bit. So yes, diet makes sense. So if you look for a relation between diet and AMD, this may be caused by macular pigment. Of course, having lutein in your serum may also influence in another way. Maybe because in serum it can lower inflammation markers. It can at the RPE have an anti-inflammatory effect or an antioxidant effect. But nevertheless, macular pigment also is an effect to consider by diet. So smoking. Well, it's also obvious to me that if you smoke, your macular pigment density is lower. This is a result from Randy Hammond's work from 1996. You see smokers, this is the distribution. Smokers tend to have lower macular pigment than non-smokers with dose response relation even. This is another paper from Randy showing the same effects. This is a paper from Malario, where he compared non-smokers and current with non-smokers with smokers, and you also see differences in macular pigment, which is significant. This is work from John's group, where they also show that there's a significant difference between smokers and non-smokers as far as MPUD is concerned, with, again, correlation which shows that the more, the worse. And this is another one from another study, where they show that heavier current smokers have lower macular pigment, and that even the relation between serum and lutein and MPUD is almost absent in smokers. A very recent one who also showed a small but significant effect in smokers. So yes, smoking may have an effect, and may also, the effect of smoking on AMD may partly because your macular pigment is lower, and then having more blue light and etc., as I mentioned. So move on to gender. Well, this is the debate. When I started into this research, gender was thought to be a risk factor for AMD. But then again, if you control for age, because women tend to live longer, so you see more women with AMD. But if you correct for this, and as I understood yesterday from Arnold's client talk, gender is no longer an issue. Nevertheless, we see some differences between men and women in macular pigment. So this is from a study from our group, where we see differences in macular pigment density. Men tend to have higher macular pigment than women. This is the same graph, and look at this. Their serum levels they are higher. So despite having higher serum levels, their macular pigment densities are low. A similar effect is found by Chula. Do I pronounce it right now? I'm sorry. Yeah. Similar effect is found by Chula, and also despite their lutein serum content or intake, which is the reverse. The Waterford group, they find in principle the same, higher densities in men than in women, despite their lutein intake is higher. And this is just a kind of model where they put in all kind of risk factors, and it still comes out if you look for gender, and this is the male component. Malario, this paper, he did many different things, also found a significant effect between men and women. This is from Randy's work, where they also see that the distribution for the women is in the lower, but for the men they tend to have higher macular pigment densities. There's another paper of Randy showing the same. Let me see, this is more recent work showing the opposite. Sorry. So it's not always. You can also find papers where they find the opposite. But in general, it's found that women tend to have lower macular pigments than men. And if you look for correlations, this is work we did, and we found that the correlation between serum levels and macular pigment density, it's much higher for men than in women. And this is found by others too. This is work from Randy showing the same. And I didn't find a graph from Liz work from 2000, but in fact she showed even an inverse correlation for women, significant, where she found a positive correlation for men. Numbers were not that high, but nevertheless they see she sees the same effect. And this is a more recent work where they looked at dietary intake, serum concentrations, and macular pigment density in spouses. And dietary intake, the serum levels, they were the same in spouses. But if you then look at their macular pigment density, here's the wife, here's the husband, then you see that the women tend to have higher macular pigments than men, despite, again, this, more or less the same intake and the same serum levels. So women tend to have lower macular pigment densities. Nevertheless, their risk for AMD is the same. So that's more or less the opposite, what you expect. Iris color, another risk factor. This is work we did. We didn't find a significant effect, as I remember, but the dark brown irises had higher macular pigment densities. The Waterford group, they found the same, I guess, that the dark did find higher macular pigment densities, if I remember correctly. As this did Randy, look, these are the means for different groups. In the browns have higher macular pigment densities. Another paper where they showed that in the dated brown tend to have more in the higher, whereas the blue-grey have lower macular pigment densities. This is another paper from Hammond showing the same. This is a recent one. It's in fact the try to read it. It's the same. The conclusion: dark irises tend to have more macular pigment, as was found by Malario in 2002. Well, this is something about the underlying cause, and well, I will reflect on this later when I look at sunlight and light exposure. So iris color seems to have an effect on macular pigment. The browner your iris is, the more macular pigment you tend to have. So if AMD is involved and you look for a relation, then maybe this is the causal relation. It just iris colors tend to have higher macular pigment, so you better protect it against AMD. So let's look for BMI. This is a paper of Hammond where this is often referred to as a BMI being a positive effect of on macular, or a negative effect, rather to say, on macular pigment density. People with high BMI having lower MPODs, but then again, look at these numbers. I mean, nobody in this audience will ever reach 40. These are the real Americans which need 2 shares instead of 1. So I don't think you should take this as a way to look for a relation between BMI and MPUD. And in fact, if you have a cutoff point over here, then the correlation isn't significant anymore. John did find a significant correlation, though inverse, but look at the number. It's only minus 0.07, so that means nothing at all. Really, that's although it's significant, but that's only because of the huge numbers you use. If you increase your number, you always will find a significant effect. But it's clinically, this means there's no effect. There is, though, an effect if you look at body fat. This is a paper from Nolan, which is a very strong or more strong effect with body fat. And as Julie pointed out, she's also, if you look at body fat, and that lean people tend to have more macular pigment than obese people. So not immediately their BMI, but more the amount of body fat that is of importance. And that could be because your body fat may be a store for lutein. Lutein is taken up, is transported by fatty particles. So your adipose tissue may be another store for your lutein and zeaxanthin. So if you have a lot of adipose tissue, then it's another source pulling at your serum levels. And if you have a lot, then well, it cannot enter your eye. And this is a study which Kirby and the Waterford group performed looking at weight loss, and they didn't see an effect in MPUD. But what they did see, if you change weight, then your serum levels increase all of a sudden, which more or less is, shows that indeed this may be the effect. So fat is a factor which influences macular pigment, but as we've all heard, you need a lot of some fat in your diet to ingest to have a proper bioavailability of the carotenoids, as it was pointed out. I just borrowed this from your sheet yesterday. Okay, let's move on to light. This is again work from Malaria, who showed that if you have and this question is a simple question here: how many times you have work outdoor during the week? And you can discriminate, and then you see if you have no outdoor activities, so there's no sunlight, then your macular pigment seems to be higher than if you are outdoor. But as far as I'm concerned, that's more or less the only publication I could find. This is a publication on Wenzel, who tried different light exposures, short-term light exposures though, to look whether macular pigment could be bleached. And he did not find any differences in two subjects in whether on light exposure. There's another paper of a German group who looked for macular pigment over a period of a year, and to see for seasonal influences. And you don't see, let's say, an effect of the summertime, where you expect more sunlight in Germany than in the winter time, and you don't see an effect. Okay. Neither did the Waterford group. They didn't see an effect in time also. So it seems that sunlight doesn't influence macular pigment that much. This is the same graph. Two papers came out recently with a very peculiar effect, and it's hard to understand this. This is a paper from John's group, where they showed that after cataract surgery, if you implement a yellow-tinted lens, then your macular pigment seems to improve compared to a normal, so let's say a clear lens, which you implant. It's, well, we could debate on what this means, but apparently light seems to influence. And maybe you should look for a longer time than just for sun. A similar effect was found even more recently by Obana and the co-workers, who did more or less the same. And although they claim their results are different, their results are more or less the same, because the trend is in the same, that the yellow lens tend to have higher macular pigment densities in the end than the clear lenses, and this age effects may just be because of an inherent age effect of the Raman technique. Anyhow, so yes, light may be a problem in macular pigment density. Well, genetics, I have some 3 minutes or so. Okay. Genetics, well, I'm a physicist, so I'm not familiar with genetics at all, and all these SNPs and things going on. So I just mentioned some papers which I encountered. Look at this paper from Lewell, which looked at heritability, and it seems that indeed macular pigment is there's some genetic factor, because it's the heritability estimates are quite high. John looked for family history, and indeed they found quite a strong effect. So there must be some genetic involved in. Then there are some genes which are related with AMD, but which are also related with lutein in some sense. For instance, this SCARP1 gene that is also involved in the metabolism of lutein. So it could well be that this is the pathway, or part of the reason that this gene is connected with AMD. Similar is for a recent found the LIPC gene, which is associated with HDL levels, and HDL is important in transport of lutein through the serum and into the eye. Another gene which is related to AMD, but also to because it can modulate blood and retinal concentration of lutein, may influence the macular pigment density, is the BCMO1 and the CD36 gene. And then I found some other literature on the ABCA4 associated retinal degenerations, and if they really did compare macular pigment optical densities, and they saw lower optical densities in the subjects having these genes compared to normal. This is work from Edelman and co-workers. So let's skip this and go on to physical activity. I'm almost there, because there's nothing to tell here. Physical activity, I've not seen any papers on this. I've only seen 2 posters yesterday. One on rugby players, what was baseball players. But then they have a lousy diet, so you cannot look at physical activity at all. And the construction workers who are physical, probably they have, although I'm not sure in Ireland, as you told us. So it's hard to tell whether physical activity only has an influence on macular pigment density. It would be hard to find a mechanism. So let this be my final slide. I had some on recent work, but I'll finish with possible risk factors for AMD, or some have strong age, which is then independent of the path is not by macular pigment. Diet, smoking could be partly because of the macular pigment, as is iris color, sunlight, and genetics. So that concludes my talk. Thank you for your attention.